Welcome to Keentel Engineering. Solar and wind facilities don't just generate power, they have to deliver it safely, reliably, and in full compliance with NERC standards into a grid that was never originally designed around variable, weather-dependent generation. That's what utility interconnection solves. In this video, we're covering the two NERC standard categories that govern this process, the 4 core challenges renewable interconnection has to address, 3 trends that are actively reshaping the future of interconnection, and how over 20 years of engineering experience comes together to get these projects across the finish line. Utility interconnection is the process of connecting a power plant, especially a renewable one, to the broader electricity grid, combining hardware, software, and regulatory coordination so power reaches consumers reliably. It's not a single step, it's an ongoing system of engineering and compliance work. Because solar and wind output varies with weather, interconnection for renewables is uniquely complex. Robust mechanisms are essential to keep power supply steady and reliable, even when the underlying generation source is inherently inconsistent. One real-world example: an interconnection review uncovered frequent false tripping from conventional electromechanical relays. The fix was SEL487E integration with multi-terminal differential protection and dynamic inrush restraint. The result was a 90% reduction in false trips, saving over $250,000 in downtime. Proof that the engineering behind interconnection has direct financial impact, not just technical value. There are 4 reasons this work is essential. First, grid stability and reliability. Real-time monitoring and control balance renewable fluctuations, preventing outages before they happen. Second, efficient power distribution. Substations, transformers, and control systems move remote clean energy to the demand centers that actually need it. Third, reduced carbon emissions. Interconnected renewables displace fossil fuel generation at utility scale, which is the whole point of building these plants in the first place. And fourth, regulatory compliance. NERC-aligned design keeps projects reliable, safe, and penalty-free from day one. NERC standards fall into 2 categories. Operational standards govern real-time operations, system monitoring, control, and emergency response protocols, keeping the grid stable as generation and demand shift minute to minute. Planning standards guide long-term system planning, resource adequacy, demand forecasting, and contingency planning to meet future energy needs before they become urgent problems. Together, NERC standards promote reliability, coordination, and compliance while actively supporting the shift to a grid increasingly powered by renewables rather than working against it. Compliance with NERC standards doesn't just avoid penalties. It ensures renewable power plants operate within a reliable, well-regulated framework built to last for the full lifetime of the asset. 3 outcomes come directly from getting compliance right: avoiding penalties, ensuring reliability, and enabling smooth technology adoption as new equipment and grid services come online. Compliance, in other words, isn't a cost center. It's an operational safeguard. Renewable interconnection has to work through 4 real obstacles. Inconsistent power generation, where storage systems and smart grid controls manage variable renewable output as it fluctuates throughout the day. Cybersecurity concerns, since IoT and cloud-based control systems demand robust protection measures against an expanding attack surface. Infrastructure upgrades, because legacy grids often need new substations, transformers, and communication networks before they can even support new renewable capacity. And regulatory compliance costs, where specialized engineering support reduces the compliance burden for smaller producers who don't have in-house teams and to manage it alone. 3 trends are actively reshaping how interconnection works: smart grid technology, advanced sensors and control systems that optimize power flow and enable real-time response across the network; energy storage integration, batteries that buffer excess generation, enhancing reliability during peak demand periods; and distributed energy resources, small-scale renewables that are reshaping interconnection needs across the entire grid, not just at the utility scale. With over 2 decades of experience, Keentel specializes in power and utility system planning, design, control, and analysis, helping renewable power plants achieve seamless, compliant interconnection from the ground up. That support covers 4 areas: NERC standards expertise, smart grid technology knowledge, cybersecurity measures, and POI, interconnection engineering support. Our team ensures your project meets compliance requirements while operating at peak efficiency, from feasibility all the way through commissioning. Let's recap. 2 NERC standard categories, 4 interconnection challenges addressed, 3 future trends tracked, over 20 years of engineering experience, a 90% false trip reduction in our case study, and engineering teams licensed across 5 states: Florida, California, New York, West Virginia, and Minnesota. Let's talk about something that doesn't get nearly enough attention in the renewable energy conversation: utility interconnection. Everyone talks about panels, turbines, and battery packs, but none of that power is worth anything until it's safely and reliably connected to the grid. That connection point is where the real engineering challenge lives. Here's the core problem. Solar and wind don't generate power on demand. They generate power when the weather allows it. The sun doesn't care what time people get home from work, and wind doesn't blow on a schedule. That mismatch between variable generation and constant demand is exactly what interconnection engineering has to solve. It starts with grid stability. Real-time monitoring and control systems constantly track what these renewable sources are doing. So, a sudden cloud passing over a solar farm or a gust front hitting a wind farm doesn't turn into a voltage spike or a cascading outage. That's active, continuous management, not a one-time setup. Then there's the physical reality of where renewables get built. Solar and wind farms are often in remote areas, far from the cities that actually need the power. So interconnected substations and transformers have to move that energy efficiently across long distances without unacceptable losses. None of this happens outside a compliance framework either. NERC standards govern almost every part of it: monitoring requirements, emergency response protocols, resource adequacy planning, contingency planning. If a plant is interconnected, it's accountable to these standards, full stop. The inconsistency of renewable output is really the central challenge underneath all of this, and the way the industry is solving it is through energy storage and smart grid controls, batteries and software working together to smooth out that variability so renewables can be dispatched as reliably as any other resource on the system. There's also a newer piece of this puzzle: cybersecurity. Modern interconnection relies heavily on IoT devices and cloud-based control systems, and that connectivity is a double-edged sword. It enables the real-time coordination we just talked about, but it also expands the attack surface significantly. Interconnection design today has to build in cyber protection from day one. It can't be an afterthought bolted on later. And looking ahead, this is only going to get more complex. Smart grids and distributed energy resources, think rooftop solar, community batteries, electric vehicle fleets, are multiplying the number of connection points on the grid. Advanced sensors and storage integration are reshaping what interconnection engineering even looks like. So, if you're developing a solar or wind project, don't treat interconnection as a formality at the end of the process. It's foundational, and the earlier it's engineered right, the smoother the rest of the project goes. If your project needs interconnection engineering or NERC compliance support, Keentel Engineering can help. Visit keentelengineering.com or call 813-389-7871. Thanks for watching, and I'll see you in the next one.